Good morning, students. So, students, waves we started last time, right? And basic introduction we had in the last class, like what type of waves are there, what waves are called mechanical, what are non-mechanical, which is transverse, which is longitudinal. Okay, so now let's proceed. So, best form of wave that we can see and experience is waves on string only. Okay, so we will understand everything from it. Okay, and then we'll apply in everything. Okay, whatever we have. Normally we have transverse wave only. So maximum we'll talk about waves in string only. But still, when we will go for longitudinal wave also, sound wave also, then whatever conclusion we are having from waves in string, that only we are going to apply. Okay, so let's see. As I told you, our focus will be on waves in string. Okay. Now, what happens in waves in string? Let's try and understand. If suppose this is a string here, okay, so this end of this string, first thing is this is string, right? This end of the string is in my hand, okay, I am holding it. Now, what I am going to do? I am going to produce oscillation in my hand. What my hand is doing? Oscillation. Okay, this hand goes up, down, okay. Hand is here, this hand is going up and down, up, down, up, down. What is happening to the next end? Suppose this point. This point also goes up, down, up, down. Next point also. Okay, next point also goes up and down. So what I'm trying to say, if my hand here, suppose the motion of my hand is simple harmonic. Okay, we have simple harmonic waves only. Okay, harmonic waves. So if my hand is doing simple harmonic motion, let's say, okay, then all these particles are also doing simple harmonic motion only. All the particles on this string are doing what? SHM. Same motion. All the particles are doing. Okay, and the energy, you all know that energy is moving like this. Whereas particles are doing SHM perpendicular. Motion of particle is perpendicular to the direction of propagation of energy. That's why these waves we are calling as what? Transverse. These are transverse waves. Okay, so all the particles are doing what? SHM. How many particles? Infinite particles. So this is a motion of infinite particles. Infinite particles are doing SHM at the same time in wave. Okay, clear? Now the question is SHM of this one and SHM of this one, are they same or there is any difference between the two? SHM is same only, but the position of the particle is not same. Position of the particle is not same, right? All particles of string are doing same SHM. Same SHM means, if I just quote what is the equation of SHM that we have studied, okay, what is it? We say that it is Y equal to A sine omega t. Okay, A is amplitude, omega is angular frequency. So if this is SHM, then all these particles are doing same SHM, same A sine omega t. Then what is different? Position. Which position? They all have to be in same. They are not. They will not be in the same position at the same time. Okay. All the particles of string are doing same SHM, but at any time t, their position is not same. Okay, we'll try and understand this. How we are saying. Now suppose that initially, initially you took your hand at the top. Okay, your hand is at the top. Will this particle also be at the top? No. Where will that be? See, if this here is at the top here, this one, then this one is over here. Like this will be the wave. If this point is A, this point is B, this point is C, and so on. Then, when point A is here, point B is here, point C is here. See their positions. Different positions. When A will come down, when A is here, then B is here, then C is here. Right? These keeps on changing. All the particles actually are doing SHM like this, but their positions are not identical. Okay, their positions are different. Is it clear, students, so far?
Yes, sir.
Okay, note it. Completed?
Yes, sir.
Okay. Alright. So all the particles are doing SHM, position of all the particle is different. Now what I want equation of the wave. What is equation of wave? Now if you look at, before also we have found equations. Equation basically is what? Equation basically means is relation which can tell us about what kind of path is wave traveling in, or relation between y coordinate and x coordinate. Okay, relation between y coordinate and x coordinate. Okay, fine. So here also I want relation between y coordinate and x coordinate because both are involved. Okay, so y coordinate, when I am looking at y coordinate, means what is y coordinate over here? Y coordinate means is which is related to the motion of particle, because energy is not moving in this direction. Okay, y coordinate means which gives us position of the particle, right? Okay, x means is the propagation of energy, right? X, in x direction what is happening? Energy is propagating. So if I have to write a relation between y and x, first of all I need to check, when I say y means position of particle. So this position of particle, this position of particles depends on x or depends on time or depends on both. That I need to check. Okay, position of particle depends on x, depends on t, or both. Let's understand. Now, if I go back again and I ask you, tell me whether y depends on x, whether position of particle depends on x, then you will ask me that which particle I am talking about. Okay, first question, which particle? This particle, this particle, this particle, this particle. Which particle? Because all are doing SHM. Whose position? So So then I have to tell you, okay, from starting, let's say 5 centimeter from the start, what is the position of the particle? That means I have to define x. Then only you can tell me what is the position of the particle along y-axis. Okay, what I asked you, position of the particle, in which direction particle is moving, along y-axis. But for that, I need to tell you which particle, because all the particles are moving along y. So which particle means I have to tell you x. So that means definitely in the waves, y coordinate of the particle depends on x also, its position along x also. Okay. So y depends on x. Depends on x coordinate. Right? No doubt about that. Second thing, time. Does it depend on time? Has to be. Because it's not that any particle I told you, okay, x equal to 5 centimeter you go, and I ask you what is the position of the particle, that particle will be there only. Is it there? No. It's changing its position because it's doing SHM. Doing SHM. So definitely it's a function of time. So it depends on time also. So in waves, position of particle depends on x coordinate also and time also. Okay. So y depends on t as well. Okay. So when you are saying equation of a wave, which is relation between y and other variables, so we will say y here is definitely function of x and time. I cannot write only t. I cannot write only x. So y is depending on x also and t also. Is that point clear?
Yes, sir.
Okay, note that one. Then we'll find the equation of the wave. Then,
Yes, sir.
okay. So see now how to find the equation. Now, suppose that at any moment we took one photograph and at that moment wave in string was like this. Okay, we took a photograph. One person is generating waves like this. Okay, took the camera and took the photograph. That means what you have done? Now you know that this was the position at this particular instant. Suppose we took the photograph at 12 o'clock. So 12 o'clock, this is the position. Okay. Now, in this one, what I am seeing, when this wave is generated, okay, when this wave is generated, initially this particle would have been at the top. Obviously, this particle would have been at the top. Like this you are generating. At some point this will be down, then it will go down, then it will come up also. So this is what? We call it as what? We call it as, we have made this string at any time t. At any time t, this is the shape of the wave. Okay, and this is what we are going to find in equation, that how we can represent a wave. Like we used to write y equal to a sine of kx minus omega t, a sine omega t minus kx. How that came, that is what we are trying to find. Okay, so this is a snap of a wave. Okay, this is at any time t. So suppose I am going over here at this point, and this is my point P, let's say. Okay, and this is x. This distance I am considering as x, and speed of the wave I am considering as v. Okay, fine. So now this point P, okay, whatever its position is, that means this position, this y coordinate. Okay, this point y, this coordinate is y. Okay, now at any time t, this point P is at this position. That also I write at point at time t. Okay, at any time t, this point is at this position. Now this particle at distance x would have been in this position. How much time before? They are not in the same position at the same time. This point is somewhere here. This point is there. Right? This point also will come at that position? Yes or no? Because we are doing it like this. So how much time before this point, this position was for this particle? You say it's easy. Because wave has taken certain time to travel. No? Wave has moved from here to here. How much distance? X distance. In how much time? X by v time. Correct or not? So this point, suppose I make not this one, I'll make it here. Okay. Is it okay? This one? Okay, let it be. Okay. So how much time before this particle also would have been in this position? We'll subtract it. How much time wave has taken to move from here to here? Okay. How much time? Distance traveled is x and speed is v. Okay. And this point will say this point is p and this point let's say is a. So we'll say if particle p is having y coordinate as y, okay, then initial point which is at a, initial point a must be in same position. How much time before? X by v time before. Why? Because wave has traveled x with what velocity? V. Okay. How much time before? X by v time before. So point A must be in same position x by v time before. Okay. So if I want to write ya, so ya definitely must be function of t minus x by v. What is this? Because this is at time t. Its function I am writing at the moment as a function of t only, because I am talking about this particle which is moving like this. We know that y equal to a sine omega t, it's a function of t. But when I am going to talk about this point A was in the same position. Okay. How much time? At what time? At t minus x by v. So function of A or y coordinate of A will be written as what? Or position of A is written as what? function of t minus x by v. Understood? Why I am doing all this? Because I know that when I have to write wave, that wave should have all the particles. I cannot write it for one function. One function means simple harmonic. One point means simple harmonic. But I need to include all the particles. So all the particles, one particle should be here. So how to write it? So what is the gap? How much wave is traveling in that time? So that I need to include. So when I include this, it takes all the particles. How? Because if this is at 12 o'clock, then little while ago, wave was here. Before that, wave was here. Before that, wave was here. Before that, wave was here. Because wave is traveling like this. Okay, so when I am writing this, I included all the particles. Because x is here. Okay, x represents positions along x-axis. So all the particles are included. And one more thing is included. What? Because we studied that wave is a function of x also and t also. And see, both are. Okay, so this is the basic form of wave equation. Now we have to change it. What? Because this is a function. And what we have to study? We have to study harmonic progressive wave. Harmonic means sine function or cos function. So we will convert this into sine or cos. Okay, so first you note this. I hope you understood what I have done. Did you understand? Students, is it clear how this came? Any doubt is there? Ask. Yes, students. Any doubt? Okay, note fast. Done?
Yes, sir.
Okay. Now this t minus x by v, we can also write as vt minus x by v. Right or not? Same function can be written like this also. Many forms are there in which we are going to write it. Okay, let's see. This is also one form. Now, before going into the other forms, that general form, a sine of kx minus omega t, there are certain things that we have to look at. What? Now, speed of wave. We all know what is speed of wave. Okay, we write as a speed is equal to frequency into wavelength. Okay, now what wavelength is? What is wavelength? Wavelength is distance traveled by the wave in one time period. Whose time period? Particles time period. Particles are doing what? Simple harmonic motion. So they have time period. Okay. Time of one oscillation is called one time period. So distance traveled by wave. Distance traveled by wave in one time. is wave. Okay. The distance is what? Speed into time, we all know. Speed into what time? Time period is v into t. Okay, that's equal to what? Wavelength, that is lambda. So lambda equal to v. And time period we can write as what? 1 by frequency. So it came speed equal to frequency into wavelength. Right? Frequency into wavelength. Okay. Now one more form we are going to use it over here. What? This frequency will convert into omega. Omega is what? Angular frequency. And we all know that omega is 2 pi into f. So f we can write as what? Omega by 2 pi. Okay, so let's do it. So here v equal to, this is omega by 2 pi. Right. Same way lambda also we are changing. Form of lambda also we want to change. What form? We are going to write it in the form of propagation constant. And for propagation constant also we know. We have studied that. What is propagation constant? We represent it with k. K is equal to 2 pi by lambda. K is equal to 2 pi by lambda. Propagation constant depends on medium. Okay, propagation constant depends on medium. For every medium, k value will be different. Okay. So lambda is what? Lambda is 2 pi by k. So this lambda I am going to write as 2 pi by k. So v value we are getting is omega by k. Okay, this is one formula and this is other formula. The speed of wave is omega by k. K propagation constant, omega frequency, angular frequency. Okay, note that. Then,
Yes, sir.
so we got this form now. So we are I'm getting confused. Okay. So this speed we are going to change as omega by k. So our form will be omega k nt. Okay. It's not necessary that it will be in this form only. That v form also can be there. Okay. But when we write, ideally we write it in terms of omega and k. Okay. So now what happens? We get the form as, this is function. Function is what? Sine here now. Okay. So we write our equation as maybe kx minus omega t, or you write it as a sine omega t minus kx, or you write it as, sorry, this is a, or you write it as a sine of kx plus omega t. Same way we can write in the form of cos also. Okay. Sine and cos, we have seen it in simple harmonic motions. Okay. Both are harmonic motion which repeat itself. Right. So, here also we are showing sine and cos functions. Does it mean that only these are waves? No. We can have even other functions also. Okay. We can have other functions also. Then how to identify? The question is asked, which represents wave, which does not represent wave. How to find? Is there any way to find that whether the particular thing is wave or not? These are plain progressive harmonic wave. Okay. These are progressive harmonic wave. And this is what we have in our syllabus. But doesn't mean that the other question cannot be asked from you, because these are the basic concepts. Okay. Harmonic means because this function, this sine and this cos, these are harmonic functions. Okay. These are harmonic. These are harmonic functions. Okay. So that's why this is called progressive harmonic wave. Progressive means what? It means a traveling wave. Okay. It's moving ahead. It's not stationary. You will be thinking, can wave will be stationary also? Yes, we will see that. We will see later on. Wave can be stationary also. Okay. So this is progressive wave. A progressive wave means it has a velocity. So whenever we talk about velocity, okay, wave function will be like this, like this, like this. How will be wave function? Wave function will be in this form: ax plus minus bt. That's kx plus minus omega t. Okay, this is must for any traveling wave. Okay, this is necessary. Then only we will say that wave is traveling. Okay, if it is not there, we cannot say wave is traveling. Clear? Second thing, when we are trying to find out that whether the particular function represents wave or not, one more thing is required. What is that? Another thing is, wave function must have definite value for every value of x and t. That means it should be defined. Whatever value of x and t you are keeping in that function, you should get a definite value. It should not become infinite or undefined. It should be defined everywhere. Then only we will say it is a wave function. We will see that. Okay. First you note this. Done?
Yes, sir.
Okay. Right. So suppose now I give you one wave equation which is not harmonic. I asked you that whether this is wave equation or not. So y equal to 3 by 4 plus 2x minus t. It's the whole square. Now question is this a wave? And answer is, we can see. We have two conditions. That third condition is also there, that I'll tell you later. Two conditions we have. First of all, if it's a traveling wave, question is what? Is it a wave? Is it a traveling wave? Is this a traveling wave? This is the question. Okay, so first let's talk about its motion. So do we have anything like ax plus minus bt form? I said yes, it is there. This is there. Okay, it is there. So if I ask you what is its velocity, can we find? Yes, we can find. How? Let's see. Okay, so first thing is this is having form ax minus bt form it is having here. So it is traveling, but is it a wave? That also we should find. Okay. So he says that this should be well defined. This y should be well defined for every value of x and t. So suppose x and t, this 2x minus t becomes 0. It's a square, so it cannot go negative. Okay. So 2x minus t becomes 0. If 2x minus t is 0, then what will happen? Is y defined there? Answer is yes. Then y value is what? Y value comes out to be 3 by 4. Yes, it has a value. If suppose 2x minus t becomes infinite, then that means very large value. If 2x minus t is infinite, then okay, if this becomes infinite, then y value will become 0. So it is having finite value for both extremes. Okay, no doubt about that. So that means y value is defined for every value of x and t. Okay, point number 1. Second point, as I told you, this form is 2x minus t. Okay, so wave has form of ax plus minus bt. So it's traveling. It's traveling. So this is definitely a wave and it's a traveling wave. Now question is, what will be its speed? Okay, so what we can do? We can compare it. With what? With what we can compare? Kx minus omega t, kx plus omega t, whatever that is. Okay, so comparing it with what form it is? Kx minus omega t. So what is velocity actually? Velocity is omega by k. That means coefficient of t by coefficient of x. Coefficient of t by coefficient of x. What is coefficient of t here? 1. So we'll write 1. What is coefficient of x? 2. So by 2. So speed is 1 by 2 meter per second. If here is given meter, then here is meter. So speed is 1 by 2 meter per second. Is it clear?
Yes, sir.
Note that. Done?
Yes, sir.
Okay. Let's see another one then. Tell me whether that's a wave or not a wave. So another one is given to you. 5 log 3x minus 4t. This is given to you. Okay, you have to find, does it represent a travelling wave? Come on. Yes, students, tell me. This is there. So that means velocity we can find. We can say it's a travelling. But is it a wave? For wave, what is the required condition? It should be defined everywhere. So, if 3x minus 4t is 0, then what is y value? Log 0 is how much? Undefined. That's all. Finished. It's not a wave. It is not a wave. Question is over. Understood that? Is it clear? Is it clear? Keep your mic open. Don't mute it. Tell me, is this a travelling wave? Come on. Yes, students. Is it a travelling wave?
Yes, sir.
This is travelling. This is not travelling. Is it? Sorry, this is not a wave. Okay. Whether this is travelling, yes. I have given you ax plus minus bt form. No doubt about that. So velocity we can find. But is it a wave? Let's see. Again, same thing we'll write. What is that? If this 2x plus 4t is 0. If 2x plus 4t is 0, then this will become e to the power 0. E to the power 0, yes, e to the power 0 is 1. So possible, then y will become 5. Then if 2x plus 4t becomes infinity, then if 2x plus 4t is infinite, then what? Then this will be minus infinity. E to the power minus infinity means what? Y equal to 5 by e to the power infinity. What else? E to the power minus infinity means 1 by e to the power infinity. And 1 by e to the power infinity means what? 0. Because e means what? E means 2.7. 2.7 to the power infinity means infinite. So 5 by infinite means 0. So here also it is well defined. Here also it is well defined. So that means yes, it is a traveling wave. Okay, so see then, two waveforms I told you which are not harmonic. Exponential, okay, and the previous one more we did know, this one. Okay, both are traveling waves and they are not harmonic. So definitely we can have waveforms which are not harmonic. Okay, we can have, but what we have in our syllabus is harmonic. So we will always represent sine and cos only. Okay, note this first. Completed? Okay. So we understood that how to find that whether the wave is traveling or it's a wave function or not. Okay. One more condition is there that I'll tell you a little later. Now we understood that what is in our syllabus. This is what we have in our syllabus. Kx plus minus omega t. Okay. Fine. In this one also we have a little problem. What problem is there? When this is minus, then what is the meaning? How is the wave? Suppose this is kx minus omega t, or this is a sine omega t minus kx. What is the difference between the two? The difference is initial difference. Okay, if sine kx minus omega t, that means the wave is like this. Wave will be generated in this way. Okay, if omega t minus kx is there, then wave is generated like this. That is the difference. Okay, this is the difference. Just remember that. How it came, that also I'll tell you. Not now, I'll tell you. Okay, and in this one, whenever this is kx minus omega t or omega t minus kx, it means is in which direction wave is traveling? Along positive x-axis. This is positive x-axis. How this came? This came from the point where we derived t minus x by v. From there. Okay, I'll just show you where it was. Here. This we did, right? You see that. In which direction I have taken the wave? Positive x-axis. And what function I am writing? T minus x by v. So whenever this is minus over here, it means wave is traveling in positive direction. So whether you are writing omega t minus kx or you are writing kx minus omega t, it's traveling along positive x-axis. Okay. Then in which way it will be traveling in negative x-axis? When I will be writing t plus. When I will be writing t plus x by v, then it will be positive, or rather negative x-axis. Okay, so I'm going back. Yeah. Okay, so when I am writing plus, so if suppose function is like this. So here how it is? Here the wave is going in negative x-axis direction, this. Okay, remember that. Note it. Done?
Yes, sir.
Okay. Now relation between velocity of particle and velocity of wave. Because we know that wave is traveling along x-axis and its velocity is omega by k. We already know. Velocity of wave is omega by k. But what about velocity of particle? That also should be there. And what particle is doing? Particle is doing simple harmonic motion. Okay. So its velocity also we know. But now we want what is the relation? Velocity of particle also I am writing. If you remember SHM, then you know velocity of particle. A omega cos omega t. Because particle which is doing SHM is, its SHM is like this. So what will be dy by dt? Dy by dt will be A omega cos omega t. Right. Another form also is there. Which form? If you remember, velocity of particle omega root over a square minus y square. This form. So these are all velocity of particle. Here also same because particle is doing SHM. It's not doing anything new. But here we want, what I want over here, relation between velocity of particle and velocity of wave. Okay, let's see. Relation between velocity of particle and velocity of wave. I am assuming that you remember this. Do you remember this? What shall I tell you? Okay, one step only I have to write. We'll do it. Okay, so this is velocity of particle. So here we have omega, then there is a cos omega t. Okay, so a omega, this cos omega t I am writing as root over 1 minus sine square omega t. Correct? Then omega here only take a inside, it becomes a square minus a square sine square omega t. So a sine omega t whole square. What is a sine omega t? A sine omega t is y. So this become omega root over a square minus y square. This is velocity of particle. Doing SHM. Okay. And this is also velocity of particle. In terms of time, in terms of y, position. Okay, because we know that when particle do SHM, it oscillates about mean position. And from mean position, if it is at a by 2, then what is its speed? We can find here. If it's at a by 4, then what is its speed? We can find it from here. And what is a? Amplitude. Amplitude means how much is the maximum displacement of the particle from mean position, right? Okay, so relation between velocity of particle and velocity of wave. So first of all, what is the relation? The relation is this. Suppose I am taking kx minus omega t form. Okay, you can choose whichever you want, omega t minus kx, kx minus omega t, kx plus omega t, your wish. Then dy by dt is what represents velocity of particle. So what's going to come? See, differentiated with respect to t. Okay, taking x constant, because you are going to talk about a single particle. When you are defining velocity of the particle, you cannot take all the particles. Single particle. Okay, so x is constant. right? So A, its differentiation cos kx minus omega t. Then differentiation of this. You have taken x constant, so its differentiation will become 0. Then here this differentiation of this, so it will become minus omega. So you got minus a omega cos kx minus omega. Okay, fine. Now what? Differentiate with respect to x also. Why? Because x has to vary. No, we have to talk about velocity of wave. Okay. So then how can we show that? So we have to make x vary, and when x varies, the particle's position also will vary. So y is also varying as x is varying. Okay. Differentiate. So when you differentiate it with respect to x, take t constant. Take t constant. Okay. So a differentiation is cos kx minus omega t. Then differentiation of kx. This time we have to differentiate because we have taken x as variable. So k and t we have taken constant. So this is 0. What we got? We got ak cos kx minus omega. Okay, fine. Now what? What is dy by dx? Dy by dx is actually slope of the graph, slope of the curve, right? Okay. Now what we'll do? We are going to do this by this, dy by dt by dy by dx. Okay, what's going to come? Let's see. This by this minus a omega cos kx minus omega t by ak cos kx minus omega t. This and this cancel, a and a cancel. Omega by k is what? Velocity of wave, right? Okay. So dy by dt minus omega by k equal to, or rather into dy by dx. What is dy by dt? Velocity of particle. Dy by dt. Velocity of particle. Okay. So velocity of particle. What is omega by k? Speed of wave. We have written velocity of wave. So velocity of particle is minus velocity of wave into slope. This is the relation between velocity of particle and velocity of wave. And what this is? This is slope. And this slope decides kx minus omega t, that equation, y equal to a sin kx minus omega t will be like this, and omega t minus kx will be like this. The slope decides. Okay. If at x equal to 0 and t equal to 0, when you are going to keep x equal to 0 and t equal to 0 here in slope, if it comes out to be positive, then this is the wave. If it comes out to be negative, then this is the wave. Okay. So here slope is negative at x equal to 0 and t equal to 0. Here slope is positive at x equal to 0, t equal to 0. What slope? You can put x0, t0. What's coming? Positive. Positive. Which form? This form. Kx minus omega t. That means this. If it would have come negative, then it would have been omega t minus kx. Okay. This is how we determine which way it is. But you don't worry. Okay. Whatever we take, kx minus omega t we take, omega t minus kx we take, everything we'll do in the same way only. So in some books you will find, if you have two books for reference, one book may be using kx minus omega t, other book may be using omega t minus kx, and eventual result will be same. So there is no problem. Okay. Note that Any doubt is there? Ask. Completed?
Yes, sir.
Okay. Now, as I was telling you that one more condition is there for a traveling wave that we will find. Okay. So what is that? This thing I am just erasing. Okay. What we are going to do, I am going to differentiate it one more time. This and this both. So one more time, differentiation. And this one. So A omega as it is there, constant. Now differentiation of cos with respect to time. So cos differentiation is minus sine. So minus sine kx minus omega t. Then differentiation of kx minus omega t one more time. What is going to come? Here we are doing it with respect to t. So x is constant. So kx differentiation 0. Minus omega t differentiation minus omega. So what we got? Minus, minus, minus. So eventual minus a omega square sine kx minus omega. Then, now this also. One more time. So d square y by dx square. Okay. ak as it is. Then differentiation of cos kx minus omega t. So again minus sine kx minus omega t. Then differentiation with respect to x. So kx differentiation will come k and this differentiation 0. So what we got? Minus a k square sine kx minus omega t. Right? Okay. Now again ratio. This by this. D square y by dx square. Do it. This by this minus a omega square sine kx minus omega t by minus a k square sine kx minus omega t. Sine and sine cancelled, minus and minus cancelled, a and a cancelled. Omega square by k square. So it is d square y by dt square equal to omega square by k square d square y by dx square. Now omega by k is already velocity of wave or speed of wave. So this we can write as d square y by dt square equal to velocity of wave square d square y by dx. This is condition of travelling wave. This is given in books. Okay, so conventional method is, if you want to find a travelling wave, whether a particular function is representing travelling wave or not, differentiate it twice with respect to t, differentiate it twice with respect to x, then find their ratio. If it is equal to square of the speed, then it's travelling wave, otherwise not. This is the condition. Okay, we are not going to do that big. I have told you smaller ways. Okay, but this is the actual condition. You have to remember this, yes, because that itself is a question. I can frame question, I can write 4 options in front of you. If you do not know this, you will do it wrong. Okay, so you have to remember, this is important. Okay, but are we going to use this to find it? No, because it takes a lot of time. Okay, note it. Completed, students? Students completed? Okay, okay. So let's start doing few problems based on whatever we have done so far. Okay, simple question I am asking. First, to start with, suppose a wave. Okay, first I'll ask you conceptual one. Y equal to a sine kx minus omega t. We have studied, this is a wave equation, standard wave equation, which is traveling along positive x-axis. Okay, now in this one, this y, okay, y can represent, okay, 4 options are there. Displacement, B, pressure, C, density, 4, electric field, 5th, magnetic field. What can be this y? Which one?
Everything.
Everything. This question is asked. This question is asked before. Okay. Why can we displacement? Whatever we are doing so far, whatever we have discussed so far is displacement wave only. What is why? Why is displacement of the particle doing as such? So we discussed displacement so far. But does it mean that we have discussed only displacement? No. We have discussed something called electromagnetic wave before. Okay, so this also we have discussed and this also we have discussed before. In electromagnetic wave, we wrote this E equal to E naught sine of kx minus omega or B equal to B naught sine or cos whatever, okay, something like omega t minus k. We have done, both we have done. Okay, pressure and density, sound. Okay, sound wave is pressure wave. Okay, and when pressure changes, density also changes. Either you will compress or you will expand. Pressure change means what? Either pressure is increasing or pressure is decreasing. When pressure increases, compression means density also increases. Pressure decreases means expansion, density also decreases. So this here y can be anything. It can be given in any form. So we will be doing the same way in all. Yes. Yes. Speed of the wave we have to find omega by k only. Okay. Maximum pressure we have to find. So A will be the maximum pressure. Same way A will be the maximum value of electric field or magnetic field. Okay. Note this one. Y can represent all displacement, pressure, density, electric field, magnetic field. Or I would have asked you, why cannot represent? And one more thing I would have written here. Okay, suppose F I am writing. What I will write F? What it shall write? Huh? Intensity. Anything. Okay. Y cannot represent. Then we will write what? Intensity. Okay, this would have been our answer. Y cannot be. Okay. Done? Completed, students?
Yes.
Okay. Okay. Now one question I am writing. Y equal to 0.05 sine pi by 2 nx minus 40t minus pi by 4. Okay, this is one equation I have written. First is very simple question that we'll do. Okay, find amplitude, wavelength, frequency, initial phase. Okay, given in wave equation. Okay, this is our first question. Let's do this first. Okay, note the question. meter. Okay. Right, noted?
Yes, sir.
Okay, let's find it fast. Amplitude. What is amplitude? This is amplitude, right? So amplitude is 0.05 meter. That's unit is given meter, so meter. Wavelength. Wavelength means what I am going to see? I am going to see that what is here as coefficient of x. Coefficient of x is 10 pi by 2. This is also there. Multiply. Okay. So coefficient of x is 10 pi by 2 and that is only k for me. What is k value? K value is 10 pi by 2. That means 5 pi. And k value is actually what? 2 pi by lambda. So 2 pi by lambda equal to 5 pi. 5 pi cancelled. So lambda equal to what? Lambda is coming as 2 by 5 meter. Okay. Lambda is 2 by 5 meter. And okay. Then what? Frequency. So for frequency, I will be looking for omega here. What is omega? Coefficient of t. Coefficient of t is 40. So pi by 2 into 40. So omega value is pi by 2 into 40. That means 20 pi. And omega is what? 2 pi f. Pi cancelled. So f is actually 10 hertz. Frequency is 10 hertz. What is initial phase? Now we know that what is initial phase, right? This is kx minus omega t. What is this? This pi by 4 is what? Initial phase. Okay? Initial phase is pi by 4. What does that mean? That means when, if suppose I am going to correlate this with waves in string that I produce by doing like this. That means I did not start it from mean position. Okay? Suppose this is mean position here. Okay, I didn't start from here. I started from some other position. Maybe start from here. Start from here. So when you are not starting from the mean position, then we will have initial phase. That initial phase. Is it clear, students?
Yes.
Okay, students. So today we are finishing here only. Okay. Tomorrow we will see it further. Right? So note fast first. If you have noted, then you can leave.
Thank you.
Okay.
Thank you, sir.